Dan Olds here, and we have a very interesting conversation with Mark Ebersole from NVIDIA coming up. He is the CUDA educator, and he's going to talk a bit about how to optimize a cluster, particularly a student cluster competition cluster, for these applications that we're going to be running, and really a lot of tips in general. Hey, Mark, how you doing today?
I'm doing good. Thanks, Dan.
So, Mark, how did you get involved with this whole student cluster competition thing?
Well, last year at SC12, I got tapped to be a judge kind of last minute. I think they were short somebody. And I hadn't really heard about the competition, so it was really interesting to go see what it was all about. And so I got to go around and talk to each of the teams and see what they were doing. And I noticed that a lot of the teams had GPUs, which was great. I was glad they were using them and recognizing, that the future is heterogeneous computing.
Mm-hmm.
And so, but the concern came up after talking to the teams that they weren't having great experiences with the GPUs. And a lot of it was just not knowing, where to go for materials or what tools were out there and available. It just wasn't clear to them where to go. And so that was kind of from a NVIDIA standpoint, kind of a red flag. If,
Sure.
These teams that are interested in using GPUs are having problems with them, that's something we need to go after and fix. So that's how I got involved with it from the NVIDIA standpoint.
It's a great competition, isn't it?
Yes, it's great, really great.
And you were telling me before that you did a lot of programming competitions and things in school?
Yeah, I did a lot of programming competitions, but this competition kind of seems like a superset of that. Part of it's programming, part of it's actually getting to play and build with hardware, and then sysadmin. I really wish I'd been involved with this back in
Wouldn't that have been
college.
Fun?
Yes.
I wish I had
great.
too. I mean,
and actually getting to travel to these big conferences, and would have been
exotic locales.
Exactly.
Salt Lake City, Denver.
A little chilly. They need to go warmer next year.
Still, great stuff. What's interesting is that the first GPUs made their appearance in 2010 in New Orleans, and just a couple of teams had them. Didn't really see a lot of kick out of it. It was still pretty primitive, and they didn't have a lot of optimized code. But it has come on year after year until I believe this year at SC13, I think every team is going to be using some sort of accelerator.
Yeah, that's what it sounds like. It's some sort of accelerator.
And we saw that at the ISC competition in June. Every team had some sort of accelerator, most NVIDIA, but also some Intel Phi's in there. So you've been to the show, you were able to judge 2012, and since then you've been working at NVIDIA to really help spread the word and get some help out there, right?
Yeah, we've been trying to just get engaged with the teams earlier to know that we're a resource for them for help and just to make available to them the GPUs and the resources and tools they need if they choose to go with the NVIDIA GPUs.
Oh, good. And they're taking advantage of it?
Yeah, most teams seem to have been sending me questions, especially and recently with architecture proposals being due. Things are starting to get into crunch mode, so a lot more questions coming in.
The serious questions, the ones that come high priority, right?
Yes, of course.
Well, let's start in general and talk a little bit about, as it says here on the slide, system setup. And don't skimp on RAM. That's number one, right?
Yeah, I mean, GPUs take a lot of parallelism and they can use a lot of data. And so we find that if you have, small amounts of RAM, then your system itself, the operating system is using a lot. And then the GPU will use what's called pin memory. And if you don't have a lot of system RAM, it's hard to keep the GPUs fed and keep them busy.
Are we looking to get to the maximum RAM per core, RAM per socket, that sort of thing?
It does. It depends on your setup, how many GPUs you have. If you have, 4 GPUs in a node, you're going to want, even more RAM than probably the max you can get. If you go down to 2 or 1, you probably don't need quite the max. But it's just a variable that some people forget to tune. They think, I'll put in, 8 gigs and be done with it. It's just another knob you can play with.
Kind of reminds me of the German coffee table of doom, where they maxed out pretty much everything and couldn't get it underneath the power threshold, unfortunately.
Yes, that's the problem. You consume power then if you max out on everything.
And so that leads us into the next bullet here. What about that ratio between GPUs and CPUs? That's tricky.
Yeah, this is a tough one, especially given the applications. I mean, if you were just LinPack, then you would just want to maximize your GPUs and have a very low CPU core count, even the lowest power you can go. But a lot of these apps are not necessarily fully GPU accelerated, so you got to have a good balance between CPUs and GPUs. You don't want to just go full accelerator, minimize your CPUs. So it's an interesting challenge.
And the best way to get to that is what? Probably through testing and playing around with the applications with different ratios?
Exactly. Yeah. You can actually shut off some CPU cores in the BIOS. So you see if that ratio helps for the overall apps, and actually keeping track of, your different scores across all the applications and see what you get.
And that's a key though, is that you want to do that pre-competition because you don't get that opportunity to shut anything off in the BIOS or to hard power anything down during the competition.
Yes, correct.
Not within the rules. So moving on, talking about administration, want to dive into the OS, right?
Yes, and I heard a quote. I'm probably going to paraphrase it here, but the best way to go fast is to do the minimal amount of what's needed. Mm-hmm. And so remove everything from your operating system that's not necessary. Any cron jobs, any services that are starting that you don't need. You want the bare bones in both the OS and your hardware.
Take out all the language support in the OS. Just really strip it all down.
Yes, exactly. The bare minimum you need. And then getting into hardware, trying to turn off everything you can. We'll talk about that, I think, a little later. Mm-hmm. But even shutting down hard drives if you can after you've booted, so you're just running on RAM. Any kind of thing you can do, or having a RAM, a network boot that comes off the head node or something. Just try to get rid of all the unnecessary equipment and software.
Makes sense because it's all sucking up power.
Exactly.
And network performance, big deal there.
Yeah, communication of data is the bottleneck in all of HPC, whether it's on chip or, external to the nodes, and networking perf is one of those key bottlenecks. So you really want to focus on getting basic tuning done, get your MPI working as fast as possible before you start having your apps use it. So that way, at least your networking is going as fast as possible, and then you aren't adding a bunch of extra layer of complexity before you try to figure out all the right knobs to tune. And if you look at like OpenMPI and MPI, there's a lot of solutions out there, and they have lots of knobs you can play with. So you really want to get in there first and get that tune for your hardware.
Mm. And direct GPU to GPU communication, that's something I heard a lot about at the last GTC show.
Yeah, so if you have multiple GPUs in a node, they can, depending on the motherboard setup, send data directly to each other, so they no longer have to go through the host memory, which speeds things up dramatically. So if your hardware is able to support this, you want to make sure it's set up and running.
But that's only if they're in the same node. But can't they do something if they're in separate nodes? I seem to remember, and why can I not remember the acronym for it?
It's a RDMA.
RDMA, there you go.
Yeah, so that just allows GPUs to communicate directly with the network card. And then, so you're not having to go through the host memory. You're not having to copy the data from the GPU to the host and then from the host to the network card.
And they can go directly GPU to GPU that way as well?
Correct. And I think most teams are using InfiniBands, which is supported for this RDMA.
Yeah, exactly. And you got a big point here on setting up the core clocks using the NVIDIA tool.
Yeah, so we have it's called NVIDIA-SMI-AC, and it allows you to play with the core clocks on these Tesla GPUs. If you need more perf and you have headroom and your power budget, you can crank it up. Or if you find you're going over budget, you can turn down these clocks and save more power.
What we're talking about here, we're talking about overclocking.
Yeah, pretty much.
Absolutely. Okay. There. Now we're making sense here. Not great for your warranty, but okay. And then pinning applications. That's a great idea because you don't want to have this stuff moving around on you.
Yep, and by pinning it to a specific core, you're also helping with caching because it no longer needs to be coherent across the cores, if it gets migrated. And also if you have multi-socket system, if teams have, 2 CPUs per node, you want to make sure the GPU is connected to its closest CPU so data transfer will go as fast as possible.
Excellent. Let's drive on and talk some general GPU benchmarking tips.
Yeah, so in general, we have these fast math libraries, which are extremely fast but lower precision. So depending on the application, that these are options to say you only need single precision instead of double precision for certain parts. Again, only use double precision if necessary. It's going to consume a lot more of the GPU's resources. So if an application only needs single precision, make sure you use that.
And that should be called out in the application directions, I would imagine.
Correct. Yep.
And if not, if you're in doubt, ask.
Yeah, exactly.
Exactly. And what is persistence mode?
So what happens in Linux if something is not using the GPU because the Linux device or the Linux operating system sees it as a GPU, it will actually unload the device driver. And so the first time you go to run it, it has to load up the device driver, and that'll add a good 2 to 3 seconds on your runtime, which can be confusing when you get different runtime variations back to back. So persistence
Ah,
mode just says keep the driver always loaded in memory. So it just starts up right away.
okay. So that's a good troubleshooting thing. If they're noticing that their times are different and they can't figure out why, that could be it.
Exactly. And you can just set this in your startup script at boot. So it's set for all your GPUs.
Okay. In ECC mode, it is fast or off, and there is risk of memory errors, but how much of a risk?
It really depends on how fast you're driving the memory clock. So part of the thing is,
That
you
gets back to
have
our
these,
overclocking then.
where there's overclocking, there's also these, pesky neutrinos that are flying through the
Well,
earth
sure.
many, constantly. And if they hit a RAM bit just right, they can flip it. It's something that you can't protect against in the actual RAM. So ECC is there to check the memory, with parity bits and make sure that things did not change in communication or while it was in the RAM.
What about a lot of aluminum foil? Is that a protection?
Unfortunately, no.
I'm talking about the good stuff. I'm talking about the thick
Maybe
stuff
double
you
that.
get from Costco, double it up. No?
Yeah, that might give you some heat problems, but
Well, okay. Little Faraday cage around your entire booth,
yeah, there you
maybe?
go.
Yeah, well. And of course, use the latest drivers, right?
Yep, almost always the latest driver and software is going to give you the best performance. You always want to check it if you're going to upgrade to make sure that it doesn't cause a degradation for some reason. But usually the latest driver will give you your best perf per watt.
Okay. Well, let's move on into your next slide, which is accelerating code on GPUs.
Yeah, so this is getting into if you're actually going to start porting some of these applications over to GPUs yourself. One of the biggest things you need to do initially is have a function check. I see this a lot where people just get excited and they get in there and start porting code, but they don't realize they've broken something until much later. So you want to
Yeah.
have this functional check, whether it's an image or an array, you're going to spit out some sort of number, and to make sure that you haven't broken something.
Ah, okay.
And it's also important to realize with floating points, there's a little bit of rounding error. So you may not get the exact number that you got on a different processor, but you just need to make sure it's within an acceptable error bound.
But it should be consistent with itself.
It really depends on where you've set the code. If you change the order of the code, you can change the rounding, how the rounding's done. And so you may get slightly different answers depending on how the code is run.
Okay. And what do you mean by profiler-driven optimizations?
This is another thing we see people make the mistake of. They assume they know where the hotspots are in code, and so they immediately go and start optimizing just, or some random nested for loops or something. What we're saying here is take a profiler, profile your code and find the hotspots, find the functions or the areas that are taking the most amount of time that give you the highest bang for buck. And those are the ones you want to go optimize and accelerate. And you just want this kind of the cycle. You move some code over to the accelerator, then profile again, find the next hotspot and move that over. So that way you're spending your most amount of time, or you're spending your time efficiently.
And just work your way through the entire code set then.
Exactly. And also, as I say here on the point, know when to say enough is enough. When you get down to, you're working on maybe 1 or 2%, trying really hard to optimize that, you're probably spending too much time there, and your time could be better spent elsewhere.
Could be better spent on other applications probably, or
Nope,
other
exactly.
spots. You want to get the low-hanging fruit out of the way and probably get, 80%, 90% of the way there.
Exactly. Yep.
Because that last 10% or so is very expensive in terms of time when optimizing anything.
Yeah, and effort, and whether you can even optimize it at all. You may spend a lot of time and finally just have to give up.
Excellent. Now, next slide, we've got tools, and you guys have a profiler.
Yeah, it's called the NVIDIA Visual Profiler. We also have the command line version called NVProf. And this will work on any code that's running on the GPU. It basically works through the hardware counters. So even if you have like an OpenACC compiled code, or, I know it doesn't matter for this competition, but we have CUDA Python now that you could profile that. So it'll show you, where the data transfers are happening between the CPU and the GPU, when the kernels are actually running on the GPU. And it also has guided analysis. It'll actually try to analyze the results for you and give you hints of where you should look next and the next steps you should take.
Does this also show how loaded the GPU is?
Yep, it'll show you how much utilization you're getting out of the GPU, and that gets into the guided analysis. It'll, say you have a low compute versus memory transfer, so you may need to add more work to the GPU without, more data, or vice versa.
Okay. That's a very handy tool.
Yes, it's a great tool. It's come a long way in the last few years. It's pretty powerful now.
Is it fairly lightweight?
It is. It runs in Eclipse, so it's it's fairly memory heavy. But what a lot of cluster folks do is use NVProf to extract the data and then just on their local machine where the profiles are installed, they'll look at the data. So
Okay.
if you don't have, a lot of these Tesla GPUs don't actually have displays, so your node may not have a display out. So you can use the NVProf to actually export the data.
Okay. And debugger for CUDA.
Yeah, if you're
Debugging,
going
important
to be
stuff.
writing CUDA C, you would want to use the CUDA debugger, and then if you're going to use Fortran for the PGI compiler, they have a debugger as well. So there are GPU debuggers where you can actually set breakpoints in the GPU code, source, single line step through the source, look at a variable in any one of the threads. So there are debuggers out there.
Excellent. And a lot of libraries, as we see on the next slide. These are
Yeah,
probably the ones that they're definitely going to need.
yeah, this is most likely what teams are going to be using are libraries to get acceleration. These are where somebody, some ninja somewhere has taken the time to really optimize some function and make it run as fast as possible, on a GPU, months and months. And there are many of them out there, both third party, external to NVIDIA that have made and internal to NVIDIA.
And a fair number of educational institutions have put together their own, I think.
Correct. Yep.
Excellent. Now let's dive a little bit deeper into the actual applications that they're going to be running on this next slide. So Wharf. I know that a lot of the teams have been accelerating Wharf. I just don't know to what extent. And we don't know that yet either, do we?
Yeah, Wharf is interesting. We've definitely seen for both, like Intel's accelerators and NVIDIA GPUs, we've seen good speed up on Wharf when looking at a single CPU versus a single CPU and accelerator. You get good speed up. But when going to a cluster level, Wharf is not as far along as we would like for an accelerator standpoint. Just as it mostly has to do with data communication, breaking up the data and getting it efficiently to the accelerators. So this is one of those applications you may get a single speed up, with just looking at one node, but you really want to measure over your whole node to make sure you're getting the right proportion of CPUs and accelerators.
Okay, so the profiler is going to help quite a bit there.
Correct. Yep.
And Nemo 5, I have another call that I'm processing, and he was talking about Magma for use with Nemo 5.
Yep, Magma is a algebra library that the people who own Nemo 5 are using to accelerate it. I know they've checked in some accelerated code into their Tapestry source that's available online. I haven't actually looked at it myself to see how much is done, but they have a good start going for teams that want to continue on and try to get use that profiler and find where the next hotspots are and see if they can do some more work themselves.
Okay, and GraphLab. I don't know a whole bunch about GraphLab.
Yeah, I actually don't myself, to be honest. I haven't spent a lot of time looking at it. I know it's a C++ based app, and when I hear C++ and accelerators, my first thought is to go look at Thrust. And Thrust is essentially if you can think of it as the standard template library for parallelism. You can call scans, sorts, reduces, all kinds of these parallel algorithms that are really well optimized to run on both GPUs and even on the CPUs with the OpenMP backend.
Okay, so Thrust is probably going to help them out at least to some extent, or at least give them a place to start.
Exactly, yes.
Excellent. And the mystery app. First time ever for this competition, for the SC competition, we will have a mystery app.
Yeah, and the mystery app, we don't know what it is. It could be any language that's supported. So the keys here are to look at things, to get to know your libraries like Thrust and the other libraries we have available, to at least know what they're capable of. So when you learn what the mystery app is, you can really quickly zoom in on the right one. But I also like to point out the OpenACC specification. And this is a way to quickly accelerate C and Fortran applications and some extent C++ by just simply you add these compiler hints into the code, or called directives.
Yeah, the directives.
So if you've ever used OpenMP before, it's very similar. You just, if you have a bunch of nested for loops, you would just put a directive above it saying, hey, compiler, I want you to go parallelize this for me and make it go faster. So it's a good technology to get experience with.
Okay, that makes a lot of sense. And having a chance to, at least knowing where to go when you get the mystery app, some things to try, that's probably going to help out quite a bit.
Exactly.
And I think keeping all of our previous tips in mind when you're thinking about that mystery app as well.
Yeah, you're going to have a limited amount of time, so you first just want to get it running and then find the biggest bang for buck and go try to get that accelerated.
Excellent. Well, the next slide, you're talking about languages here.
Yeah, this is just I wanted to point out for the first point that, you can write CUDA code, which is meaning you're actually programming for the GPU in C, C++, Fortran. I put Python here, but it's probably not going to matter for this competition.
Yeah.
So this is for when you're looking at maybe some Wharf code. There's some Wharf code out there that was written with CUDA. So you're actually going to go in and write CUDA code directly for the GPU. So CUDA is what you want to go to when there's a library doesn't do what you want. OpenACC is not doing what you want, and you really need the most flexibility is when you would go down to that level.
Okay. And we do have OpenACC, though, in order to give us a little higher level, a little higher language play there to
Yep,
be able
and
to quickly do this stuff.
yeah, and if teams are interested in the PGI OpenACC compiler, since NVIDIA recently bought PGI, we're happy to give a license out to the teams that will last through the competition, so they don't have to worry about that.
That's good. Have you had many tap you for that yet?
Yes, we've had it. We've definitely had a couple, and even for their CPU compiler, because PGI has a really
Sure.
solid CPU compiler.
Yeah, and you have here in the last bullet that it is a potential leg up for the mystery code.
Yep, you
Doesn't
can get
hurt.
some very quick acceleration with just a couple lines of code.
And we talk a little bit here about the education that you guys have out there. You guys, there is a lot of material out there.
Yeah, this is just a small part of it. I was just trying to get some of the core ones the student teams would be interested in. Big ones, docs.nvidia.com, especially the best practices guide. It really goes through into detail a lot of what I'm talking about here on accelerating codes on the GPU, as well as just documentation in general on all our libraries that we support, CUDA code and everything. It's all contained there in docs.nvidia.com.
Excellent stuff. And then we have where to get help. There are a lot of forums out there too.
Yep, the two we recommend most is DevTalk, our NVIDIA's DevTalk forums, and we have our what I call it, our ninja programmers, our developer technologists. They monitor this to help answer questions. And then Stack Overflow is also a great place to go ask questions. I think we have long surpassed the 3,000 plus answered questions on CUDA. So there's a good chance if you have questions, somebody's already asked it and it's been answered. So those are our two forums we recommend.
And I've gone out and been on a few of these forums just looking around, and it's a pretty patient crowd out there too.
Yeah, yes, patient, and they've been answering a lot of the the new questions, the intro questions for quite a while. So they're pretty, they're
In other words, don't
good.
feel dumb to go out and ask a question. As long as you've looked and you can't find an answer to it, go ahead and ask.
Exactly.
Very good. So, any final words of wisdom to the students out there?
I guess also make sure you enjoy the conference while you're there.
Yes.
Don't just get too focused on competition. It's you've been working for it for many months, but it's a good opportunity at this conference. Lots to learn, lots to see. Stop by the NVIDIA booth, say hi to us. We've got lots of fun stuff going on there.
You'll have the lanyards, of course.
Yeah.
That's the NVIDIA trademark lanyard that's been at every show for years now.
Yep, get your lanyards, get your swag. It's,
Got to get the swag. That's right. But make sure one of the things that I would advise is when you're swag hunting, go get the bag first.
Yes, very important.
It's like Halloween. You want to get the bag first, and then you start filling in the swag inside.
And don't be afraid to ask for things. A lot of times if you ask, you'll get it.
Yeah, actually, at the last SC show, I ended up coming home with about 4 pounds of pasta.
That's a new one.
Some vendor there that had some pasta manufactured for them. It was pretty good.
I'll have to check that out this year.
Yeah, let's see if they're there again. I'll let you know.
All
Well,
right.
Mark, great to see you, and I guess we'll see you at SC13 in Denver, right?
Yeah, definitely. I'll stop by all the teams and make sure to say hi.
Excellent. Thanks again, and thank everyone out there for listening. We'll talk to you soon.